Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about sequence items in UVM. So basically in UVM, the sequence item is one of the most fundamental building block. It is going to represent a single transaction or a set of related data items that are going to pass it between the components in the test bench, or you can also say that are being going to pass it by the driver to the DUT. Okay. So basically what is this sequence item? So this sequence item, it is a base class. UVM sequence underscore item it is a base class in UVM that is used to define the transactions, also known as sequence items, and it extends UVM transaction which is extended by UVM object. So this is the hierarchy which we are going to follow from the UVM void. So this is the parent class, we already know. This is the top class UVM void, and from this UVM void, so UVM object has been this is your UVM object is your child class, and from UVM object there is one more child class which is known as UVM transaction. Okay, so from this UVM transaction we can derive our UVM user defined transaction, and from this UVM transaction another class has been derived which is known as UVM sequence item. Okay, so from this UVM sequence item we are going to define our user defined sequence items, and from this UVM sequence item one more class has been derived which is known as UVM sequence base, and from the UVM sequence base we have one more class which is known as UVM sequence, and from this we are going to get UVM user defined sequence. Okay, so we are not going to discuss now this. Okay, so we are going to discuss this now. Okay, we will discuss after this discussion. We are going to discuss about these classes. Okay, so basically this UVM sequence item, it is a base class in UVM that is used to define the transactions. Okay, now so basically where we are going to use this UVM sequence items. So basically this UVM sequence items will be used in the sequences. Okay, so UVM sequence item is typically generated by a sequence, a subclass of UVM sequence, and sent to driver via the sequencer. Okay, and what it is going to carry, so the UVM sequence item is going to act as a container for the data, for example address, data, read, write, etc. So this is analogous to a data packet or a bus transaction. For example, if I want to analyze this, let's say this is my test, and inside my test I have my environment, and in my environment I have one more class which is known as agent. Okay, now in this agent I have a sequencer and a driver. So I have a sequencer and a driver. So this is my sequencer and this is my driver, and this is my agent class, and this is my environment. Now so let's say this is our DUT, this is our DUT, and the test and the DUT are connected in the top module. I'm not drawing that. Okay, so this is our design. Now let's say this design is a bus which is nothing but AMBA AHB bus or AMBA APB bus. Okay, so basically if we are seeing this AMBA AHB or APB, so if we consider our DUT as a AMBA AHB bus, so regarding this protocol we have so AMBA AHB protocol also we have our recordings which are available on our channel. You can browse and you can learn about AMBA AHB protocol in detail. Okay, so I'm considering this protocol signals. So my design is expecting let's say it is expecting H write signal. Basically it is a AHB slave. My design, it is a AHB slave, so it is expecting H write signal and it is also expecting H trans signal. Okay, so let's say these are the signals which our design is expecting, and H trans, and let's say H write, H trans, and H burst. Okay, let's assume this signals our design is expecting by the test bench to be driven. Okay, now who is going to drive these signals, H write, H trans, and H burst? This driver, it is going to drive these signals to the DUT. So the driver, it is going to drive the signals to the DUT via the interface. So using the interface, the driver, it is going to drive the signals to our DUT. This we already know. Okay, now where is this signals, where are the values of the signals, like H write is equal to 0, H write is equal to 1, where are this getting from, or where are this getting randomized from? So these randomized values are being getting from our sequencer. Okay, so this sequencer is providing this randomized values to the driver, and it is not sending one by one value. It is not sending h write once, and it is not sending after that hw data, and after that it is not sending h burst. No, it is not sending like this. So it is basically sending the objects. So it is basically sending the objects. So this object, it is going to contain all the three data items. In this particular example, this object, it is going to contain all the three data items. It is not going to send each and every individual data items. No, it is going to wrap up all these three data items into an object, and this sequencer, it is going to send it to the driver. Now this objects is known as your sequence items. These are known as your sequence items. Now, these sequence items are acting as a container which is holding your randomized data. Okay, so the sequence items are basically acting as your container which is holding this randomized data. Now, how this sequencer is getting this randomized data? Because in our previous session we have already seen this sequencer, it is just acting as a bridge between your driver and sequence. Okay, so the sequence, it is basically generating this randomized data. It is wrapping all the data inside an object, and this sequence is sending this objects to the sequencer, and the sequencer, it is sending it to the driver. Now these objects are nothing but our sequence items. So there will be a sequence which will be present, and this sequence will not be a part of your test bench hierarchy. So this sequence is not a part of test bench hierarchy. Whereas this sequencer, driver, agent, environment, test, these are all the part of a test bench hierarchy. So these are all known as components. Whereas sequence, it is not a part of test bench hierarchy, and it is independent of this test bench hierarchy, and it is known as your object. So this sequence, it is so basically this sequence, it is going to randomize the data which is present in the sequence items. So there will be two classes. One is known as sequence and another is known as sequence item. So in this sequence item, we are going to declare all the data items. What are the data items? I will write down here. So we will have basically two objects. One is sequence and another is sequence item. So basically this sequence item, it is a class which is going to hold your h write signal, which has been declared with rand keyword h write and rand h trans and rand h burst. So like this, inside your sequence item, all the signals will be declared. Now this class sequence item this class handle will be declared inside your sequence. So the sequence item class will be declared inside your sequence. So sequence item class will be declared. So the sequence item class handle will be declared in the sequence. Now what is the sequence it is going to do? It is going to create the object for the sequence item. It is going to randomize the sequence item, and it is going to send the sequence item object to our sequencer, and further it is being sent to the driver. And driver, what it is going to do? It is going to open up this object and it is going to pass each and every individual signal to the design. Okay, that and all process we will see in our next upcoming sessions. But for now, what is our requirement is to understand the sequence items. Okay, so basically I will explain this one more time. So what is our requirement? Our requirement is that driver should send this three signals, which is known as h write, h trans and h burst to our design. But the driver, how it is getting this signal values h write, h trans and h burst, the sequencer is providing these values, and the sequencer is not going to provide each and individual values to the driver. It is not going to provide h write once, and it is not going to provide h trans next, and it is not going to provide h burst. Okay, so it is basically sending an object which is containing all these values, all the randomized values of h write, h trans and h burst. Okay, now how this sequencer is getting this particular randomized object? It is getting it from the sequence. Okay, so basically there will be two objects. One is sequence item and another is known as sequence. Now sequence item is going to contain all the data items declared with rand keyword. Sequence item is a class which is going to have all the data items which has been declared with the rand keyword. Now the sequence item class handle will be declared in sequence. The sequence item class handle will be declared in the sequence. Now, the role of this sequence class is to randomize the data which is present in the sequence item and send this object to the sequencer, and that object will be sent it to the driver. So this is how the flow of data will be happening from the sequence to the DUT. So this is how we are going to happen, and about the sequence also we are going to discuss it further. Okay, in our further sessions we will discuss about the sequence also. But for now, our main agenda and our main goal is to discuss about sequence items. Now, how to declare a sequence item? So let us try to understand how to declare a sequence item. So let me write down a simple example of a sequence item. So we can simply write class sequence underscore item, which is extending from the parent class, which is known as UVM sequence underscore item. So this is the parent class which we are having. Now, what is the first thing we should do? So we should basically declare all the contents which we want. So the data items which we want is rand, what is that we need? H-write. So it is rand bit H-write, and what we need? Rand bit, and H-trans, it will be basically 2-bit width. So this will be according to the protocol. Okay, so you can just watch the recordings of our AHB protocol. So we have rand bit 2 down to 0 H burst. So these are the signals which we have in our sequence item which has been declared. Now, so we are going to register our class tick UVM underscore object underscore utils, our class name sequence underscore item. And if you see here, it is not a component, it is an object. So that's why I'm using, for the factory registration, I'm using tick UVM underscore object. Okay. And followed by new function new string name. That's it. So what is the name? You should provide this, and followed by super.new and followed by end function and end class. That's it. So this is how we are going to declare a sequence item. So this sequence item, it is simple. So just this, like this, we are going to declare our sequence item, and the sequence item class handle will be declared inside our, and this sequence item will be used with our sequence, and the sequence, it is going to randomize all these values. Now let us try to understand UVM sequence. So basically this UVM sequence is also being derived from UVM object, and from UVM transaction, UVM sequence item, UVM sequence base, and from this we are going to get our UVM sequence, and from this UVM sequence we are going to declare our user defined sequence. Okay, so this is the class hierarchy for this UVM sequence. So basically UVM sequence, it is a container that is going to hold the data items, that is UVM sequence items, which are sent to the driver via the sequencer. So the UVM sequence, it is going to send the data items, or you can say UVM sequence items, which are sent to the driver via the sequencer. So basically UVM sequence, it is a parameterized class with UVM sequence item. So basically UVM sequence class, it is a parameterized class, and what is the parameter we are going to provide? That is a sequence item which we have declared. Okay, so in this case we should write the parameter as this sequence item. Now how to declare this UVM sequence? So we will just simply write down class, let's say AHB underscore sequence, and this should be extended from extends UVM underscore sequence, and this is a parameterized class. So hash my hash, and what is the sequence name? That is sequence underscore item. So sequence underscore item, that parameter we should pass here. That's it. And after that we should register this class with our factory registration. Factory registration will be present here, and after that your new function new, all the code will be present here. Next, so inside this sequence we will have a task which is known as body. So inside this sequence we will have a task which is known as body. So in this task we are going to So in this task, which is known as body, here we are going to perform uh, all the operations which are in this task body. We are going to perform all the operations like randomizing the data, sending the data to the sequencer, and getting response from the sequencer. That and all the tasks which will be performed in the body task. So body task, in this body task only we are going to perform all the functions which are related to randomizing, sending the data to the sequencer, and receiving the responses from the sequencer. In this body task we are going to do. Okay, so how to declare your sequence class? Sequence class, just declare your user defined sequence class name, which is extending from UVM sequence, which is a base class, and the parameter is a sequence item which you have declared previously, and register it with your factory and new function, followed by body task is very important. Inside your body task only you are going to declare all the functions which you are going to perform, like randomizing the sequence item, sending it to the sequencer, and receiving responses from the sequencer. Now, how to randomize the things, how to send the data to the sequencer, how we are getting responses from the sequencer, that and all we are going to learn now. Okay. Now, so what is this body method? So the operation which is intended to do by the sequence is defined inside a body method. Just now declared now. Just how we have discussed it now. Yes. So along with the body method, we have basically pre-body method and post-body method are called by default. Okay. So in the randomization, if you remember in SV also when we are discussing, so when we call this randomized method, there will be two methods which will be called, which is known as pre-randomized method and another is post-randomized method. So similarly, in the case of body also, if we are calling this body method, we will have the two methods will be called, which is known as pre-body method and another is post-body method. So basically this pre-body and post-body tasks are additional and can be named as callbacks. So this can be also called as callbacks, which are callbacks we will discuss later in our upcoming sessions in the UVM. So basically these are useful for performing any operation before and after the execution of the body method. So this basically pre-body and post-body methods are optional. Now, for creating a sequence item. Now, just now we have discussed, previously we have discussed that our sequence item class is going to hold the data items which are being declared as an AND keyword. Okay, so these data items in the sequence item class, we have declared them. Okay, this we have declared and these are being declared with rand keyword. Okay, this we have already seen. This and all we have already seen. Now we need to randomize this data items. We need to randomize this data items. Where we are randomizing this data items? We are randomizing this data items in the sequence class. Okay. Now in the sequence class, for randomizing this data items, we are going to randomize this data items in the body of the sequence. Okay, inside the body of the sequence only we are going to randomize the data items which are present in the sequence item class. Now, so to create the sequence item, how to we cannot randomize using the handle name, right? So we should first create the instance of the sequence item, then only we can randomize it. Without a object, how we can call the randomize method? No, right? So first of all we should create the instance of the sequence item now, and we need to randomize it. Okay, so first step is inside the body task. Inside the body task, we need to create the instance of the sequence item. Next, using this instance, we are going to randomize the data items. After randomizing this, we are going to send this to the driver. Via the sequencer. So this is a method. These are the three steps which we are going to follow. So these are the three steps which we are going to follow. The first step is to create the instance, and second step is to randomize the data items, and third step we are going to send this data items, randomized data items, to the driver via the sequencer. This is the intended functionalities which we need to follow in the body task. Now, so there are basically two methods for performing all these operations. Okay, so basically we can use macros such as UVM do, tick UVM do, and tick UVM create, and tick UVM underscore send. Okay, these and all macros which we can use. Okay, next is using the methods from the base class. Okay, so in the base class, that is UVM underscore sequence, we have basically built-in methods. We can also use them. So what are the built-in methods? We have wait for grant, send request, wait for item underscore done, or else we can use this methods that is known as start underscore item and finish underscore item. So why are we using all these methods? Our agenda is simple. We need to perform three operations, that is creating the instance, randomizing the data items, and send it to the driver via the sequencer. So these are the three operations which we need to perform. For performing these three operations, we have basically three methods. One is you can use macros, or else you can use built-in functions. Built-in functions also, there are two type of built-in functions. One is you can use this category A, or else you can use category B. Okay, now let us try to understand what are these macros, what are this category A built-in functions, and what are this category B built-in functions. Okay, let us try to understand all this. Okay, and please remember, what are we doing in the body task? The operation which we are doing in the body task of the sequence is simple. Just we are creating the instance, just we are randomizing things, and we are sending it to the sequencer. So performing these three operations, we have these built-in methods.